I don't know what I'm doing here. I'm not shipping the way we want to, bleeding users. It's time for a Hail Mary. If I send you a photo and you view it, your device has to say, I viewed this photo, so the system can know to delete it. If you're an engineer, you go, wait, how does that work, right? And the answer is, well, it can't provably do it. He says, I've got a great idea for how the app should be. Please redesign it in a month. Why don't we just try it? Like, why don't we just do it? Because what do we have to lose?
Today, I have Ben Hollis here with me. Ben is an engineer who's worked at Amazon and Snap. He spent 10 years at Amazon working on internal tools, databases, and Amazon Go, store where you just pick things up, walk out, I'll charge you for it. And then he spent 8 years at Snap, where he led the infrastructure team. And that's what we're going to talk about today, where he was one of the most senior engineers, maybe?
One of, yeah, for sure. I'll give it one of.
One of the most senior engineers who actually led a full stack rewrite of how Snap worked, all the way from infrastructure up through client libraries, iOS and Android. And today we're going to walk through that journey, what Ben learned about it, and how we move forward from there. So Ben, welcome to the show.
Yeah, thank you. I'm glad to be here.
So I was looking up some numbers from Snapchat. Snapchat's a fascinating company because I remember there was a whole like social media war in 2015 or 16 where the Snap numbers were growing. It was insane.
Yeah.
It was like 100 million, 200 million DAUs. And then Instagram launched Stories. And 6 months later, for the first time ever, the numbers lurched. Like, you all actually lost users.
Yeah. It's a tough time.
It does not seem like a pleasant time. This is shortly after you joined, right?
Yeah, right. Yeah, I joined in 2015. So, we had been there a year or two, right?
So, yeah, we're early on. But the journey after that, I feel like the whole world wrote off Slack or wrote off Snapchat after that. The journey, though, like Snap absolutely reaccelerated. Today, they're at 500 million or so daily
almost,
active.
Yeah, almost there. Yeah.
Yeah, which is an enormous number. It's like twice what Twitter and X, whatever, has, and they won't even tell us at this point. That was the last high water.
Right. Yeah, Twitter was always MAU, monthly users, and Snap always reported DAU, which is like totally incomparable.
And yet still much higher. So
still much higher. Yeah.
A huge effort. But this infrastructure and this full stack rewrite infrastructure through client happened right at that lurch. So tell me a little bit about what was going on at Snap at the time. What prompted this rewrite, and how did that feel after that decline?
I mean, it was pretty insane, right? I mean, like you said, Zuck had noticed the acceleration of Snap as well, had famously tried to purchase Snapchat a few years earlier, right? And then, at some point decided, why compete when you can clone, right? And so the Stories clone had come out. We were, I don't know how we were reacting to it exactly, but we didn't really react to it. And then I'm trying to think, it was October, November of that year. Evan, the CEO, came back with an idea for a redesign of the app, like a really drastic redesign that moved Stories around and put it on the left side of the app, redid how we were going to think about content, all this stuff. And that started a death march, like a real deal death march, because he was like, well, and this is relevant, but like, he was like, back in the day when it was me and my buddies sitting around the table in my dad's house, we would ship things really, really fast. And people have not been shipping things fast at this company in the last couple of years. And I'm frustrated about that. I have this cool new idea. I've just seen some cool apps in China that do everything and blah, blah, blah. Comes back, he says, I've got a great idea for how the app should be. Please redesign it in a month and rebuild it completely. A month. Yeah. And our team had just actually come off of a death march, shipping a separate feature And so we were immediately retasked to rebuild some portion of this grand redesign. And so everybody did that. And actually we were up in Seattle, but a lot of the team, most of the team was down in LA. They all got stuffed into an aircraft hangar and spent a month on at long tables, like typing away at code, Android and iOS code. It was mostly client focused redesign, right? The back end wasn't really touched, and just like moving everything around. And as you can imagine, that wasn't a super fun process for anybody involved. Right? It just wasn't
charming, but maybe not pleasant.
Yeah. And so the month came and went, and we hit the deadline. We rebuilt it as we were supposed to, and we didn't ship it then. They said, "Oh, we're coming into December. Apple traditionally takes the month off.
Oh my god!
We really don't. We got a few things we still want to do. We're not going to actually launch it at the deadline." So we had just run off the end of the cliff. Very tired. I flew down to LA to visit everybody at the hangar and see how they were feeling. The mood was not ideal. But what's important in this part of the story is toward the hangar, I got pneumonia. I got really sick because it was all these humans crammed into one place. And again, this was 2017. We didn't know what it was like when you put a lot of humans in one place, right? We didn't know about illnesses and things. So I got like really sick, like really, really, really sick. So I was like out of commission for the rest of December. And I came back from that healed up, and I was like, I don't know what I'm doing here, right? Like, I don't know. Yeah. I don't have a thing to do. The momentum had stopped, and I just didn't have an idea. And so I was like, I don't know if I want to continue at Snap.
That's the in question.
Right. Yeah. And I'm like really doing the soul searching. Momentum had been cut from being sick. And I went, if I'm going to stay here, I need to do something really meaningful and really big. And having just been in the guts of all the systems, I said, I've been working on the side and all these other systems. I want to attack the core of the app. And that meant messaging, right? Snapping, chatting, video calling, like all the core parts of like why people adopted the app in the first place. And I thought, there's so many things about the architecture of that system that I saw we couldn't ship the features we wanted to quickly, like the way Evan wanted to, right? He had gotten used to that, sit at the table, come up with an idea, ship the thing. We weren't doing that, right? And I thought, like, it's the architecture of this that is causing that. And if you look back, it totally makes sense, and it was reasonable, right? Like, it had evolved from a very simple app. Like early Snapchat was you could only send pictures. Then they added chat. Then they added group chat. Then all these features, but they accrued organically. And so that architecture was just really, really messy, and like you couldn't really change it in any reasonable way. So anyway, it's a digression, I guess. But like, I was like, I want to really redo that. I want to fix that. And then separately, I was like, well, another thing I could do is I could change the way we do our backend infrastructure, because we were in a huge monolith, all on Google's App Engine, if you remember that. We were the biggest consumer of Google App Engine. And, that had honestly worked really, really well for us, but we'd outgrown it, right? So again, it was slowing us down. Everything was in one big blob. We needed to move to a service-oriented architecture, something like that. So I was like, if I don't do the chat thing, I'd like to work on this infrastructure thing and change the way we build and deploy and manage services and how they talk to each other and all that. So I went to our head of engineering and I said, here are these ideas I have. I'd like to do this. And he said, great, do them. Yeah, definitely do that. And I'm like, well, which one? He said, just do all of them. Just do both of them. Yeah. It's like, all right, great. And I didn't really know what that meant at the time, but rather quickly, me and my co-founder here at Stately, but like, at the time at Snap, we got, given the messaging team and told to, all right, great, you had an idea, make it happen.
Awesome.
Which is kind of wild.
Terrifying. So tell me a little bit more about what it looks like to like bite that off. Because conventional wisdom for even medium-sized migrations is like, what can you break up? What can you do separately? What can you define? What can you let burn? But it sounds like you both had the idea and then got the mandate to like go blow it all up. Have fun.
Yeah. There was a lot of buy-in, honestly, which was shocking. Like,
Yeah.
I
Where is that coming from?
I mean, I think everybody had seen it, right? They'd seen the slowdown in innovation and the ability to ship and how complicated things had gotten, and how tough it was for anybody to get anything out without breaking things. Yeah, and it was just like, why, honestly, there was a feeling, why not at that point, right? Like, go big or go home, sort of. We're in this place, we're kind of in a slump, to rejoin the story of the redesign. Like, it didn't go well, right? The redesign we had all cranked on. If you look at the curve of users for Snap, that's where it actually starts going down, right? And some of that was Instagram stories, but some of it was this redesign in the middle that, for better or worse, just changed the way people interacted with the app, and they didn't like it. So we're in this phase where, like, we're not shipping the way we want to. We're bleeding users. Things aren't great. It's time for a Hail Mary, right?
Mm-hmm.
And to be clear, we weren't the only Hail Mary. There was a lot of stuff going on, right? Everybody was scrambling to do stuff. But in our part of the world, the idea was get us into a great place for messaging where we could continue to innovate on features. The other thing is, like, the infrastructure cost was insane. And I can't possibly quote real numbers, but like, you wouldn't like them. It was far too high. And, again, as a consequence of it being a system that had evolved, right? Cost wasn't a huge concern, but, now when you're paying historic checks to Google and Amazon, you start to care about it, right?
Yeah, absolutely. I do remember the Snap S1, which it was shortly around this time, had numbers to Google that were promised and specific, and they got a reaction on the internet, like easily hundreds of millions of dollars of
it was a lot
per year.
Yeah. So we thought, well, we can fix that. We can fix the innovation slowdown. We can fix everything all at once. You're right. It's totally insane. Like, we knew at the time it was insane, but there was this mood of like, well, why don't we just try it? Like, why don't we just do it? Because what do we have to lose, right? And so the idea of breaking it up, logically, we should, right? Like, and we all knew that, right? Almost all of our team had come from Amazon. We'd seen huge migrations there. We knew the ones that went well and the ones that went badly. We knew all about how to do this stuff incrementally. But we sat down at the whiteboard and just started sketching out how these systems would work. And we're like, okay, we're going to need a thing over here, and this is going to talk to this, and then we're going to need a system that looks like this and looks like this. And the more we wrote down, the more excited we got. And we were just kind of like, we can actually just make this stuff happen, and the outcome will be worth it. Well, that never works. To be clear, it never works. When you get excited about that and you draw the huge system, you never actually get to make it. Now, we did, like, just to spoiler it, but like, yeah, it shouldn't have worked.
It should, but yeah, spoiler, it did. Tell me, I think one of the things you mentioned as we were chatting before this, which I thought was so super fascinating, is that when you do these incremental migrations, you sort of define the value really well. If we're going to upgrade, the tiniest thing is this service gets a bump and it will have these three things. But there are full system properties that are not available if you're doing things incrementally. And similarly, you sort of mentioned, we've talked about DAUs a couple of times. Like, that is the number that you all were measured on internally. So tell me a little bit about the kind of, like, you were operating at a totally different altitude here. What full system properties were available to you? And how did you start to think about like, here are the pieces that'll line up, that'll deliver those that we could not possibly do in smaller chunks?
Yeah. I think the one that was kind of most critical there was the interaction between the client and the backend, right? So Snapchat's has a lot more logic on the client than you would expect. The client's super fat, super smart, and a lot of that comes back to the way Snapchat works, right? So Snapchat famously deletes your photos. If you're an engineer, you go, wait, how does that work, right? And the answer is, well, it can't provably do it, right? And I'll say like we do delete the photos, like everything that happens in the TOS happens, but it's a process that has to have cooperation from a client, right? So like if I send you a photo and you view it, your device has to say, I viewed this photo, so the system can know to delete it, right? So the client is much more interactive than, say, I don't know, a WhatsApp or something that just has to send and receive messages and call it a day and nobody cares. So we had this really, really fat client. And what that meant is that we couldn't really get all the benefits that we wanted by just fixing the back end. And we couldn't really fix just the client without updating the back end, because the back end was entirely built to support the client as it worked at that moment, right? So you had this interlocked system where you're like, well, you know, and we had tried. Now, let's be clear. We had tried like, oh, we're going to focus on just the client. We're going to make the client great. But the interaction models, the APIs, the exact way they worked, how data could be loaded, when it could be loaded, you were really, really constrained. So there was only so good we could make the client in isolation. And then we had tried to just make the backend better, but the client is interacting with it in a certain way. You can't really improve it there. So that's why we really had to, and we did much more than this, but at the very least, we had to keep the client and the server kind of being rebuilt at the same time, right? So that's kind of how we like backed into that.
Interesting. That makes a lot of sense. That what were some of the hairier features you had to support there? I know that Snap has tried a lot of stuff, and there's sort of this famous, as you're alluding to, like this famous model of like Ev drives that company. Ireland drives that company a lot more directly than a lot of other companies do.
Yeah. I mean, there were two kind of categories there. One was the more mainstream features that were just really, really complicated. And you go again, like, well, what's so complicated about Snapchat? The most complicated thing we hit was the feed. And I don't know if you're familiar with Snapchat, but the feed has, every conversation that you have with your friends or groups or whatever, and then it has a little icon. And the icon is red or is purple. Nobody, aside from a couple of people, knows what red and purple mean, but it's very important it gets it right. And then there's a little text that says, something about the last action. And then when you tap it, different things happen. Maybe it plays the snaps, but if there are chats, it might go into the chat. But if there are chats and snaps, then it has to play the snaps in a certain order and then get you to the chats. That logic of even just showing what to show and then what the interaction is mind-blowingly complicated. Really, like very, very difficult. And it was one of those things where, you had the load-bearing engineers on both iOS and Android who like, this person knows how the feed logic works. And they're the only person who really knows it, and they have it in their head. And if you need to change something, you have to go talk to that person, right? There was a lot of that sort of stuff. And then on top of that, again, because the client was super smart, there was an Android implementation and an iOS implementation. And they were written by different people at different times. And the logic was slightly different. So that was the other thing. You could ask, oh, well, how's it supposed to work? And you go, well, on Android or iOS. Which one, right? Yeah, so that sort of stuff was really, really, really complicated. The other category that we ran into was features that honestly didn't exist anymore, right? So like a good example was Snap Cash. For a hot minute, you could send money through Snapchat. Right. Yeah. Everybody was doing it at the time. And there was a really cool announcement video. and feature was out there and people did it. And then that got pulled out of the app and stuff, but people could have saved those messages. So you still need to show them in your archive of messages if somebody had saved, a receipt for something, but you can't send them anymore. Supporting that sort of stuff.
Supporting it.
Yeah, some of that stuff is really crazy to support because, how do you even get one of those, right? You have to go find one and see what the format is. And of course, none of this stuff was documented or anything like that.
Of course not. No. Feature doesn't exist anymore. Why does it need to exist?
Right. I mean, yeah. And again, it's all logical, right? These were features that were built as an experiment really, really quickly, thrown out there. Okay, they didn't work, pull it out. That's fine. But then when you put in the constraint of, well, I'm going to rewrite the entire system, it needs to support every message that's ever happened. Well, now you have to care about this thing again that was just a one-off, right? So
interesting. Oh, I love that. How did you think about the I'm really fascinated by like the full stack nature of this migration. That's there's a whole write up on the Snap Engineering blog about like your work around Envoy and what the control plane looked like, and at the same time you're often the client rewriting logic, figuring that out. How did you get people? I don't want to use the word alignment because that feels very like management-y. If you're trying to create whole system properties, like you got to get the people talking to each other. Like, what language did you use?
It was tough, right? There were two things here, right? I mean, Snap was not a very command-driven hierarchy within engineering. So obviously for product, what Evan says goes, and he has his group of designers that work with that. And like, so how the product works, how it looks, what it does, very command driven. For engineering, it was a lot more, independent silos and different groups doing different things and not a lot of commonality, honestly. So this was another place where we drew from our experience at Amazon, which, well, there's some things that it would be a little easier at Amazon. But the idea there was for infrastructure tooling that we wanted people to use, we just were going to build it and hope it was so good that people had to adopt it, right? Like that they saw it and they went, wow, like I couldn't live without this. Right. And so that actually influenced the design of a lot of this stuff. So, it was all meant to be very loosely coupled and easy to compose. And a lot of the stuff, like you said, we were doing with Envoy, and we had a really cool little control plane for that, was to make it so that teams could own services, be loosely coupled to each other, and then declare, whatever, a retry policy or a timeout or a route to a different region or something like that in some really declarative way and not have to coordinate. So in a lot of ways, the software itself was enabling that loose coordination between teams. Like if we had a really command driven hierarchy and everybody could be told, you're doing this now, you're all writing everything in Go and you're doing blah, 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 blah. I would have architected something else, right? I would have built something slightly different because we could, that's like the Google model, right? Just tell everybody what to do and they all do it.
Yeah.
But yeah,
I understand it doesn't work there either. That you still
sure. But they don't have to ship products.
Also that.
Oh, but yeah. So in a lot of ways, I felt like the infrastructure part was architecture, like engineering for the organizational properties that we had, and building software that like meshed with how people were thinking. And part of that was like, we didn't have to run around and convince people quite as much, right? Like it was designed specifically to help avoid having to have those conversations.
Yeah, absolutely. Going back to the idea of like engineering is loosely organized. If you put something out there or if you put something out there and you got this Hail Mary kind of moment that's happening, like people are standing on the sidelines going like, oh, I can pick up this thing and run with it. That makes a ton of sense.
Exactly. So if you were a team that like didn't want to be an app engine anymore, and a lot of them didn't, and you wanted to use Go or you wanted to use Python or something like that, what were your options? Well, you could forge ahead on your own, or you could use this new thing that we built that's really cool that plugs into everything else. And well, you're going to use that, right? So
I've met like 3 engineers who would forge ahead on their own, and nobody else wants to.
yeah. And that's the same thing. We learned that at Amazon too, where like really early on, we built these service frameworks and there was no mandate to use them, but everybody used them, right?
Yeah, absolutely. Did that approach, which is super common in infrastructure, did that scale? Like, did you see um, the same kind of like build it and they will come approach work for, say, the front end and the mobile clients?
Um, Front end was especially hard, actually. That's a really interesting one to bring up. Front end for Snap meant Android and iOS mobile apps, right? And folks have a real identity around that stuff, right? Um, I don't see too often people saying like, "Oh, I'm a whatever Go developer." Like sometimes you'll say, "Oh, I'm a Rails developer, I'm a Django developer," or something like that. But people really are like, "I'm an iOS developer. Like I specialize in the iOS platform." And a lot of times that means specializing in Apple or Google's APIs, the way that things are supposed to be built there. And then when you scale out to something where you're like, like what we did with the messaging thing, where we said, well, you're not going to write in the platform language. You're going to use this C++ layer that's shared between Android and iOS. There's a lot of pushback on that, right? It's very, very unfamiliar. And so those took a lot more convincing, honestly, to say, okay, yes, you're going to have to let go of a lot of this code, but I promise you it'll be better. It's a hard argument to make, right? Until you kind of at least built the shell of it and put it in there and gone like, look, now you're not having to worry about coordinating every request and, computing the new feed update model or whatever it is, right? And then they say, oh, okay, yeah, actually that is pretty easy, right? But that one was a much harder pill to swallow, I think.
Mm-hmm. Yeah, that's interesting. So you actually went in and shipped like code APIs for them. That's like library, use this, and it solves some of your problems. So it was really philosophically the same. Like I'm going to provide you with internal tooling that solves the problem, but it's really interesting you ran into that kind of resistance.
Yeah. And again, it was just a really, really big change. Like a counterexample, Snap has an internal UI framework that's a cross-platform UI framework that I think they're open sourcing pretty soon. That one was more of a build it and you will come sort of thing, where it was built off on the side, used for a few features. Some people saw it and went, wow, this is really, really great. So then they use it for their feature and it sort of spread organically. So it can happen, right? Is what I'm saying. But I think it's harder on the front end and especially mobile, right?
Yeah, makes a ton of sense. So tell me, like, if we zip ahead in time a little bit, tell me a little bit about landing this plane. Like, what were the big chunks that of work that landed, and how did you see those roll up into like, yeah, we did it?
Yeah, it was, and I'll apologize if my memory is a little fuzzy on some of this stuff, so I might get the order a little bit wrong. But basically, we built an entirely new backend, right, as a separate service, separate database. I mean, the old stuff was in GCP, the new stuff's all in Amazon, DynamoDB, completely new API, completely new service, blah, 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 blah. And then we built a backwards compatibility layer in Java in the App Engine layer that could call either our new service or the existing stuff. And so we supported all the existing APIs in terms of the new service, right? That was like the craziest part of the whole thing, right? Because then we had to be bug by bug compatible with the old system on a completely new API, which we had just built, which we didn't know worked yet, right? Right? Because we hadn't built the client for it yet, really, or we were in the middle of building the client for it, right? So we were like, I think this is the model for this. And then you'd build your compatibility layer and you'd say, oh, well, we totally forgot about this type of message that we'd never heard about, right? That has these types of properties. We need to build that in. So it was very, very iterative. So we built that, we launched that. and we had metrics, right? So this was like the most important part is we did a dual read write mode where on a per conversation basis, we could say, well, I'm going to clone it in the background and then split the writes. And you're still using the old system. Your data is mastered in the old system, but there's a copy. And then we diff everything at the point at every API, every response, everything coming in, everything coming out. And then we'd publish metrics. So we'd be like, all right, for bog standard text messages, 100% match. No problem. We've got it. For snaps, every once in a while, there's a difference. What is that? Okay, well, I'm going to go in and investigate. I'm going to look at the logs. Oh, yeah, okay. In 2010, there was a type of message that was written for a couple of years that had these properties, and then that got back, et cetera, et cetera. And then also, keep in mind, we're reinventing every other system at the same time. So that's causing other changes. That diffing system was like the key to making this seamless, right? If we didn't have that, it would have been, I don't know, YOLO, it works on my machine, right? Like, because really quickly we had, I can bring up my Snapchat. Oh, I'm using the new backend. Like, it works. It's great.
Yeah.
Well,
I can build Snapchat in a weekend, especially today.
Yeah. But does it really work for the trillions of saved messages? You're going to want a little better assurance for that, right?
Yeah.
So absolutely. that was like step one. And even that we did it like separately for one-on-one chats versus group chats, because in the back, they were entirely different systems. And then we were rolling out this new client, right? That this cross-platform C++ client that had been built from the ground up. And that only spoke the new API, right? Because we weren't going to put all the effort in to make it speak on the client, both the old and the new API. So now you have, with the new API. So now you have to coordinate a migration in the back end where conversation by conversation, you might switch it over. And then the client can say, well, of the 300 conversations I have going on, some of them are on the new system and some of them are on the old system. So I get to switch which API I use and, which library I use dynamically. So et cetera, et cetera, et cetera. And it's actually way, way more complicated than what I'm saying, because you also did this on a conversation level and on the feed level. It was a whole thing. Very, 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 very complicated. But the point is, what the key of it and what made it even possible was we were breaking down the problem into the smallest chunk we could, right? So if I could say, well, you don't migrate a user, you migrate a conversation, just one conversation at a time, right? That is something, and you build all the infrastructure to be able to flip, okay, this conversation is in dual write mode, okay, now it's fully migrated. I understand those states. I can communicate that to the client. The client can then choose which library to use to actually interact with that. It made it very, very controllable. And it also meant that we could start rolling out, oops, something went wrong, roll it back. Clients never know, right? Nobody ever noticed any of this stuff was happening. There weren't outages. There weren't bugs. Like, nobody saw it. Yeah, nobody noticed it during this entire thing. But it was because we had that infrastructure in place to make that sort of stuff happen.
Yeah. That is, okay, that makes it all make much more sense. You weren't rewriting the whole system. I mean, you were, but you weren't rewriting the whole system all at once. That by picking not user, not screen, but conversation through this, you were full stack rewriting each of the types of data or the types of like interaction that Snap provided. That is still a big deal. Still a lot of work, but it makes a lot more sense because not only are you moving them over one at a time, you're moving them over. You've got levers at every layer by vertical slice. So everything is just a little piece and you can do it incrementally.
Yep. And then all backstopped by those metrics that make sure, that we didn't mess something up in the middle. Right.
Yeah. Yeah. Those metrics are absolutely key. That's a theme. That's like a theme of this show at this point. It's, but it's not how Slack works. It's a way that like Datadog cut over the APM product, the new data store. It's that you need to know, is this thing working? And it's not just like, did I test it outright? I mean, just last week we were talking with Renard at SourceGraph, and he rewrote the query parser. It's the same thing. And just like, does the new system parse the queries in the same way as the old? I think he used the phrase bug for bug compatible as well.
Yeah, yeah, exactly. I feel like there's really a discipline and a science to this, and like a methodology, and like you should teach it in school, right? Like there should be a class on migrating, migrating from one thing to another, because it's important and it always has to happen eventually. Um,
This idea of grouping by user level visibility, like that's the grad level version of this, that the default version of this is like, I look at a request and I do the compare, but I don't have this. I either do something very coarse about who gets flipped over, like organizations, uh, or it's just like totally random, and then you just kind of shrug if the user doesn't get the right answer. But this is really smart. I love that.
yep. And we ended up, repeating that pattern. Once we had that machinery for doing migrations, we were like, wow, we're power basically, right? Like we can migrate anything. So that was like one of the follow-ons we did right away was, and this is part of our original plan, but we regionalized the service. So it previously had been only one region, but we said, okay, well, I would love it if your data was close to you. If you used Snapchat from India, it was a very bad experience because you had to go all the way to Iowa. And, we talked to a lot of people about how fast the speed of light was. And we suddenly realized, oh, well, we built this system for moving data from one place to another and making sure it actually matches. And we can just do that for regionalization. So we reused that whole system to actually, once we had the new system, to move data from one place to another. And like, so I'm not going to, I would never say it was easy, but it helped.
You mentioned when we talked before that there are some experiences about messaging in Snap that no other platform has been able to replicate. What were those?
Trying to remember exactly what I was saying there. I mean, a lot of it. This is just me bragging about how much we did, but like we had an obsession with cost, right? Which translated to an obsession with size. So the size of messages, because it directly turns into your bandwidth bill. For Dynamo, it turns into your storage bill, right? But we realized that it also turns into, well, how many packets does the cell tower have to exchange with the device to get a message in? And as a result of that obsession with size, we pretty much kept everything in one packet. Yeah, I mean, any snap that you get sent, like not the image itself, but the data about the image is one packet. Any chat, assuming you didn't write a lot of text, right, fits in one packet. There's a variable component, right? And so because we had cranked the metadata down and like, boy, we really puzzled out every last byte from these things, we could keep everything in one packet. Having one packet meant fewer retransmits in a bad network condition. So you actually will find if you like go out into the boonies where the cell signal is pretty bad, Snapchat will work. You can still chat with people. It might be a little slower, but it'll still work. Facebook Messenger, not going to happen, right? iMessage, not as good, right? So it's kind of wild to be like, oh, I can't iMessage people, but I can still use Snapchat. I guess we did a pretty good job, right?
That's cool. Yeah, that's the kind of thing that you just can't incrementally improve towards. I mean, you can get there, but like you need to touch every part
exactly.
of the system.
And for us, like that was the design of the API, the design of every single data structure, moving to gRPC from a JSON based thing. When we did our C++ client, we ripped out the networking layer and replaced it with Chronet, which is Chrome's underlying network thing. We were the first to use gRPC C++ on mobile. Like it was just all this stuff that we had to do. And, some of it was principled and some of it was just like, I really want to save every last byte.
Awesome. So this was eons ago. We didn't know about either respiratory diseases or EI. What would you have done differently if you had the tools that were available today?
Yeah, it's super, super interesting. I mean, I think I can imagine a ton of stuff that we could have done with the help of AI, right?
Mm-hmm.
Obviously, we didn't have any of that at that point. I think when you pair up the AI tools we have now with a a backstop that's real, like that's provable, I guess is the thing. So for us, that would be those metrics and those logs that make sure that you haven't screwed stuff up. The pain of creating that backwards compatibility layer could have been vastly accelerated, right?
Yeah.
Because what it really came down to was reading thousands and thousands and thousands of lines of obscure undocumented code, trying to figure out what the behavior is, more or less guessing, okay, I think this is how this works, deploying it, waiting for the metrics, waiting for the logs, looking at the mismatch logs, going, okay, puzzle this out. I can easily imagine building an LLM agent loop for that, where you say, okay, great. The LLM every day looks at the logs, figures out what the bugs are, goes, changes the code, tries it again. Hey, we could have all been on the beach sipping Mai Tais while this thing like self-organized itself. Maybe.
Yeah, just
Right?
incinerating tokens. But yeah, I mean, it's a great point, right? Like you had manually built this structure of like what is the smallest unit of change? Like it's a conversation, all the way through, or if a conversation, maybe even at a couple of different levels. And what is what does good look like? You got those logs and metrics, and it's only at that point that you really, it's almost a little bit of a knock on current AI usage. It's like you got to do all the work that you just talked about before you can even bring AI to bear. So like, yeah, the last 20% gets faster, but
It's just like how if you're using the coding tools today, the difference between doing it with a test suite uh, and not is huge, right? And for us, the metrics and these diff frameworks were the test suite effectively. The best part about it is they weren't a synthetic test suite; they were real live production data, right? So we knew for real how it was gonna work out.
yeah, yeah, you're never questioning the test suite. Like, is this testing the right thing? Like, oh,
Yeah, and I think I see that as being the future of a lot of this stuff is if you can pair up an agent that can affect change with a system that can accept change safely, right? Validate the change. So either it's impervious to breakage or because it operates with some rules or structure, or whatever gives you the way to do it in shadow or some of these other techniques. If you incorporate a lot of these techniques, then you can really let loose these agents. And whether you say, okay, it's Claude or it's an army of interns, right? It's just effectively the same output, right? They're going to go and do a bunch of stuff, and as long as they have the right fences around them, you can get a lot of great value out of that.
yeah, yeah, that really resonates. That there's so much that open loop it doesn't do well. I think the other thing that I've seen a bunch of is that I've seen people using AI to try and spin up these frameworks faster because it's now cheaper to get there, and you realize the benefit on the back end. But it's like a fundamentally different type of work, right? Because you throw it away.
It totally is. Yeah, I'm trying to think of like how much of the actual framework could we have built. And I mean, obviously you could scaffold a lot of it, but I think you would need a really careful eye in validating that the framework works. Once you got the framework working, you've effectively got a playground, a sandbox that you can put anybody in, right? Whether it's an LLM or a human. And, if you've made it safe so you can throw anything at the wall and you won't break something, then yeah, go nuts, do whatever, right? You can be as bold as you want. You can take as many risks as you want because there aren't really risks, right? You've already fenced it in.
Yeah, absolutely. Even if it's only 20 or 30% cheaper, actually, you'll create the framework. The gains you pick up by having it are just so much more valuable. I love that. That makes sense. So what did you learn from this experience, and what did you take to your next gig?
Yeah, well, I'd like to say I learned not to do giant, ambitious infrastructure projects, but that's clearly not true.
Awesome.
I'm still addicted to it. I mean, a lot of what we took away from it was that these sorts of frameworks don't exist, right? They're not off the shelf. And like I was just saying, having a system that kind of programmatically reduces risk of change is like a key unlock to being able to go nuts, and whether that's product innovation or doing a crazy backend rewrite or whatever other thing you want to do, right? Save costs, whatever. So that's why when we left Snap, we were like, okay, what could we build that embodies these principles, and that's why we're building this database, StatelyDB, that lets you change anything about your schema, anything about your data model, kind of any way you want without ever breaking prod, right? Which again, talking about ambitious infrastructure projects. But yeah, that's the idea, right? And again, it comes back to what we were trying to do there with Snap. We had an idea in our head of here's what we want our ideal data model to be. Clearly, our data model's holding us back. But how do you affect that change? Well, it's a huge project. Well, does it need to be a huge project, right? Why can't the database help me with that? Why can't it, programmatically understand the sorts of transformations I'm trying to do, build that backwards compatibility layer for me automatically, and then, I'm off to the races. So that's what we're building, right? Change anything you want anytime, automatic backwards compatibility. So you never change, you never break your existing clients, but you can forge ahead with your new projects, unconstrained.
That makes a ton of sense. And it feels like another brick in the house of where I'm hoping the world gets to, which is like, I basically want to see the world, move away from as much tech debt and legacy code as possible. And the two pieces you need for that are you need fundamental building blocks that are changeable. Like if you have a database that you cannot change, then that becomes something that you have to put wrapping paper around. Like that's where the other half of this is what we're doing at Tern, right? Of like, let's help you put more wrapping paper around things and move things incrementally. But like, maybe you wouldn't have to do that so hard if the underlying code would, if everything was as easy to change as code. Code is, well, it's not trivial to change, but it's a site easier to change than a database in most cases.
Well, it's easy to change if you don't care about anything that's currently running, right? Right. It's super easy to change, right? Like just go for it. Oh, everybody's broken. Whatever. They should upgrade, right?
It doesn't have to be reliable. I can make it real fast.
Yeah, exactly. And so, what we're thinking is there's got to be infrastructure primitives that let you change at the speed you want without having to know all the history of, whatever 10 years of bedroom development, right? Without breaking things, right? And that can be built into the infrastructure. And then once you've got that primitive, like what can you do, right? If you have a database that you can't break and you won't break your existing applications by changing it, what would you build, right? How much faster would you build?
Mm-hmm.
And then, can you extend that to other types of infrastructure? I bet.
Probably.
But again, I don't want to go too crazy on huge infrastructure projects, right? No more of that for me.
Just the databases.
Just a database, just
corner of the infrastructure world.
Yeah, exactly.
Very cool. Well, this has been a fantastic conversation, and I could talk about this all day, but unfortunately, we are running out of time. One last question for you, I guess, too. Where can folks find you on the internet? And how can they help you?
Yeah. Well, so a bunch of us who built all that stuff at Snapchat are now at Stately Cloud, building StatelyDB. Our website is stately.cloud, so really easy to remember. So come check us out. We'd love for people to give us feedback, try things out, talk to us. If you've ever had the problem of trying to change anything about your infrastructure and especially your database and have found it frustrating or difficult, or you gave up because you didn't want to, please talk to us. We'd love to talk through your problem and see whether we can help, or if not, whether we can learn from your experience.
Awesome. Sounds great. Well, Ben, thank you so much. This is an amazing conversation.